everyday learners, you've already done this already. So you guys will just have to, it will be a revision for you guys. So you've got Theorem One, which is you are given AC is perpendicular to OB, and then therefore AB is BC. The theorem here, it says if a line is drawn from the center is perpendicular to the chord, therefore this will be equals to that. So this thing this way is going to be a problem. I'm going to confuse the other keys. 150. Okay, I'm not going to prove the theorems, we're just going to read through them. Okay, so this theorem, it says the line drawn from the center of the circle perpendicular to the chord, it bisects the chord. So bisecting, this is a chord. Bisecting the chord, it means is cutting it into equal parts. So that's the equation. Yeah, okay. So the line drawn from the center of the circle perpendicular to a chord bisects the chord. Okay. The next theorem is I think it's just the converse of that, where it says the line drawn from the center of a circle into the midpoint of the chord is perpendicular to the chord. So you have a line drawn from the center and to the midpoint of this, right? Then they say it will be perpendicular. So midpoint, which means already they are giving you that this is equal to that. So you have A, B, C. Here you are given that AB is equal to BC, and you are proving that, therefore, OB will be perpendicular to ABC or AC. So if you are given that the line from the center already, it is drawn to the midpoint of this. Midpoint is in the middle, so which means this and that are equal. If this and this are equal, therefore that line is perpendicular to that line. So that's the converse for theorem one. Then the next theorem, this one, where you've got this, and you've got this, and that, and also this, and this. Okay, so you've got O2, O1, you've got D and E, and then you've got B here. Okay, so this one, you are given point A, B, C, D, and E are the points on the circle with the center 0. You are given those points. Then conclusion here is that O1 is going to be equal to 2E, and again, which is 2D, also O2 is going to be equal to 2B. This theorem is theorem 3. The angle at the center, the angle subtended by an arc at the center of a circle is double the size of the angle at the subtended by the same arc on the circumference of the circle. So remember, the circumference of the circle is this. This is the circumference of the circle, right? So they say the angle at the center, this is the center, subtended by an arc. This is an arc. An arc is just a piece of the circumference. So if you see arc AC subtend angle AE, it also subtend angle D, if you see where I'm highlighting. So the angle at the center is twice the angle at the circumference. Angle at the center, twice this angle. That's why O1 is 2E and is also 2D. That's it. I'm not going to do a proof because that requires a lot of time. And also, the same theorem, O2 is twice B. Angle at the center, O2 is the angle of the center, subtended by this arc AC. That arc AC already also subtend the very same the angle on the circumference, okay, on the other side. So O2 is this side, is subtend this angle. O1 subtend the other angles. Okay, so that is that theorem. And then the next one is, you've got this. E, F, G, C, K, B, A, C. Okay. Here you are given that AB is equals to DE. Then conclusion is C is equals to F. Let's read the theorem. So this is equals to that. That means this angle is equals to that. So that theorem, let's see where it is so we can read it out. Equal chords or arcs subtend equal angles on the circumference of the circle. So you see, this is an arc, right? Or a chord. A chord is just a line joining 2 points on the circumference. So this chord is equal to that chord. That's what you are given, that AB is DE. So if you've got equal chords, then there is subtend equal angles, opposite angles. So that means this angle is equal to that. Angle opposite the chord, angle opposite that chord. So if these two chords are equal, therefore their angles are, their opposite angle opposing those sides are equal. Okay, so that's that one. Then the next one.
Ma'am, please read theorem 3.
Sorry? Should I repeat the one? The one that I just did, or this one?
Yes, ma'am, the one you just did.
The one I just did, okay. The one I just did, they say equal chords, right? So chord AB is equals to chord DE, right? Equal chords subtend equal angles on the circumference of the circle. So this chord is subtend that angle, right? Subtend this angle C, right? Chord AB is subtend angle AC, right? But we said chord AB is equals to chord ADE. So they say they subtend equal angles. This chord which subtend this angle is equals to this chord, and this chord subtend angle A. Therefore, their angles are equal because they say equal chords subtend equal angles on the circumference of the circle. It must be on the circumference of the circle. Okay. Happy?
Yes, ma'am.
Right. Then let's move on. The next one. Next one is this one. Okay. This is the diameter. Then it's an angle at the circumference. Okay, so you are given that AB is a diameter. If AB is a diameter, therefore angle C is 90 degrees. Let's see the theorem. The diameter of a circle subtends a right angle on the circumference of the circle. Diameter of a circle AB is a diameter. It subtends a right angle. Right angle is a 90-degree angle at the circumference, right? It must be at the circumference. So if this was subtending an angle here, this cannot be 90 degrees, okay? Because it's not at the circumference. It must be at the circumference of that circle. Okay. Okay, then the next one is this one. It's a lot of them. So next one is, come on, the pen is starting now with the stories. That's a straight line, please. So here you've got A, D, B, C, and they say A, B, C, D is a cyclic quad. You are given that A, B, C, D is a cyclic quad, and then therefore angle A will be equals to angle B, angle C will be equals to angle D. Let's read the theorem. Where is it? Oh, where's the theorem? Where are you? Oh yeah, it is. The angles subtended. Yeah. The angle subtended by a chord of the circle on the same side of the chord are equal. Angles subtended by the same chord. Remember, a chord is just a line from joining 2 points on the circumference. So chord AB subtend angle D, and the very same chord AB subtend angle C, right? So they say angles subtended by a chord of the circle on the same side of that circle are equal. You see, they subtend them and on the same side. Therefore, these angles are equal. Okay. Then the same thing. So that's why C is equals to D. CD is also a chord if you look at it. And that chord subtend angle A and also subtend angle B. Therefore, angle A will be equals to angle B. So they say the angles subtended by a chord of the circle on the same side of the chord are equal. Okay, so that's that. Okay, next one is just the chord, the what? Okay, it's just the converse of theorem 4. So converse of theorem 4, if a line segment joining 2 points subtends 2 equal angles at the 2 other points on the same side of the line, then these 4 points are concyclic. So let me change the pen. They say if a line segment joining 2 points subtend 2 equal angles. So you have a line segment, this one. Okay, so if you have a line segment, right, joining 2 equal points, 2 points subtend the equal angles, right? This is a line segment, just like a chord, subtend 2 equal angles. So if already they tell you that angle A, what's that? Angle A is equal to angle B, right? This is the line segment. It joined 2 equal angles, right? So A is B. Therefore, this ABCD will be a concyclic, which means actually ABCD will be a cyclic quad. It's a cyclic quad. So if you prove that A is equal to B, or you are given that A is equal to B, therefore this is a cyclic quad. Or if D is equal to C, this will be ABCD will be a cyclic quad. Okay, so that is that one. And the next one is another quad related cyclic quad. You've got 4 points. Okay. So this one, you are given that A, B, C, D. This touches the circle. You're given that ABC is a cyclic quad. ABCD is a cyclic quad. Okay, so if this is a cyclic quad, that means angle A plus angle C is 180 degrees. Okay, that theorem, it says the opposite angles of a cyclic quad are supplementary. Opposite angles, this is opposite that. When you add them, supplementary angles, they add up to 180. So when you add these two, they give you 180. So if they tell you ABCD is a cyclic quad, then you know their supplementary angles, they will add up to 180. These are also their supplementary angles. So also B plus D will be 180 degrees. Okay. So that's that one. Another one is just the converse of this. If they tell you that A plus C is 180, therefore this will be ABCD will be a cyclic quad. Okay. Or they tell you B plus D is 180, therefore this will be a cyclic quad. Okay, so that's that. Then the next one, another cyclic quad, they give you this.
Then
Yes.
can you say that B and C are equal to 180 because they are co-interior angles?
No. A plus C or A plus D.
D plus C.
D plus B.
C, ma'am. D
C.
plus C.
Oh, D plus C. You can't say that because you don't know if these lines are parallel.
Okay, ma'am.
Yeah. If you knew that these lines are parallel, then you can say D plus C is 180. The co-interior angles. Okay.
Yes, ma'am.
Yeah. Okay. Then let's see this one.
Nah, I forget.
Okay. See you later. We are together. You're online. You're not muted. Okay. The next one, we've got A, B, C, D, 1 and 2. This one, you are given that A, B, C, D is a cyclic quad. Okay. If ABCD is a cyclic quad, therefore C1, this is C1. Exterior angle of a cyclic quad is equals to interior opposite angle. Okay, let's just find the theorem and read it. Where is it? The exterior angle of a cyclic quad is equal to the interior opposite angle, just like that. Okay. Then the opposite of that, which is the converse of that. If they tell you that C1 is equals to A, then you know that therefore this is a cyclic quad. Okay. So you see, so far we did 3 things that involve a cyclic quad. So if you were to be asked to prove that something is a cyclic quad, you will need to have prove that exterior angle is equal to interior opposite angle in any one of those. Either you prove exterior angle is equal to the interior opposite angle, therefore that will be a cyclic quad. Or when you add the interior opposite angles, they add up to 180. So if your interior opposite angles are supplementary, therefore that will be a cyclic quad. And the last one which we have done, it was this one. Okay. If you find that this angle is equal to that angle, therefore this will be a cyclic quad. The same as if this one will be equal to that, therefore that will be a cyclic quad. So these are the 3 conditions. If they ask you to prove that a certain thingy is a cyclic quad, either you prove this one or that one or that one. As long as you can just prove one, therefore you can conclude that that is a cyclic quad. Okay, so that is that. Then the next one is a tangent from the same point. So if you've got this, okay, this point P, this is point A, this is point B, right? This is a circle, center O. They tell you that the theorem says if two tangents are drawn from the same point outside a circle, they are equal in length. So you see AP, they tell you AP is a tangent and BP is a tangent. These two things, they tell you that they are tangent. If those two are tangent, they are joining, they are coming from the same point outside the circle. You see, they are coming from point B. They're joining from point B. Therefore, PA to be equals to PB. That one is easier. We can try to prove it quickly for you guys. So you will construct this line here, construct this one. So this is your radius. Center to the circumference of the circle is a radius. Even this is a radius, right? So let's prove. If you look at triangle AOP and triangle BOP, what is equal in those triangles? Can you see that OP is equal to OP on both triangles, which is a common side? And can you see that AO is a radius, also OB is a radius. Therefore, those two things are equal. The reason being because they are radius. Okay, two radiuses. And also, this angle is 90 degrees because a tangent, angle A is equal to angle B, which is 90 degrees. Our reason here is because always remember that tangent is always perpendicular to a radius. Even in analytical geometry is applicable. Tangent always perpendicular to the radius, therefore that angle is 90 degrees. Therefore, can you see we've got side angle. This is a condition of congruency. Therefore, triangle AOP is congruent to triangle BOP. And if you remember conditions of congruency, is either you've got all sides that are equal, or side angle, or side angle side. Oh, this is the same as that. Or angle side angle. The other one is right angled hypotenuse side. So once you prove that the two triangles are congruent, then all these are applicable. Therefore, if this is a congruent, therefore, we can conclude that the corresponding sides AP is equal to BP. Okay, right. So that is that. So the guys that are new, my learners, we've already done this. So that's how you prove that. Let's move on. Time is going. Then the next one is, hopefully we can do one exercise from the exam paper. You've got a tangent here, touches the circle there. We've got the center. That's a straight line. So this one, they're telling you that tangent is perpendicular to the radius. So if tangent is perpendicular to the radius, they tell you that ABC is a tangent. Okay, and therefore OB in this case is perpendicular to ABC. Okay, then if that is if OB is perpendicular to ABC, therefore if ABC they tell you is a tangent, therefore OB is perpendicular to that. That's the reason. That is called, that theorem is, where is it? Which one is this one? Tangent and radius. Yes. Laptop is doing. Okay, it's fine. But that's the tangent that is always perpendicular to the radius, right? That's that one. Then the last theorem is a Tangle theorem. We've got a chord here. A tangent, sorry. Then we've got this. Okay. So they tell you that this is a tangent. You have a chord here. So if ABC is a tangent, therefore angle, this one will be equal to this one. B1. Give that another name. B1 will be equal to angle E. Okay, that's the Tangle theorem. It says the angle between a tangent to a circle and a chord drawn from the point of contact is equal to the angle in the alternate segment. So angle between this tangent and a chord drawn from the same point of contact. So this angle is equal to the angle in the alternate segment, the angle in the other segment. So that's the angle. Okay. So that is a Tangle theorem. The converse for that, if they are telling you that B1 is E, therefore this will be a tangent. So if they tell you that B1 is equal to angle E, therefore ABC will be a tangent. Okay, right. So that is that. And I'm sure you all know about parallel lines. If we've got an F shape, these lines are parallel, these angles will be equal. If you have a Z shape, this line is parallel to that, then these angles that forming a Z will be equal. If you've got a parallel line and this, if this is parallel to that, co-interior angles will be supplementary. So this plus that will be 180. So I'm just gonna go quick. Then angles on a straight line, if we were angles on a straight lines are supplementary. So this angle plus that must give you 180. Angles around the point, this angle plus this one plus that one must give you 360. Vertical opposite angle, this angle is equal to that angle. This one is equal to that angle. That's that. Then your triangles, you've got angles of a triangle are supplementary. So this plus that must be 180. And then exterior angles of a triangle equals to the sum of the two interior opposite angles. Okay. And then equilateral is a triangle that had equal sides and equal angles. So this side and that side is equal. And these equal angles are all equal to 60 degrees. Because if A, B, and C are equal, A plus B plus C must give you 180 angles of a triangle. But A is equal to B, which is also equal to C, which is 180. So 3A is 180. Therefore, A will be 60, C will be 60, B will be 60 degrees. Okay, that's that. And then also the last one on triangles, if you've got two sides that are equal, angles opposite equal sides are equal, sides opposite equal angles are equal. So if they tell you that AC is equal to BC, therefore angle A will be equal to angle B. Angles opposite equal sides are equal. And also, if they tell you that these angles are equal, therefore the sides are equal. That's just the vice versa of that. Okay, so that's it. Let's quickly, we have about 15 minutes. Let's go to the question paper. Where is the question paper? And see if we can be able to answer anything. Okay, let's see which question number is the Euclidean. I think it's somewhere question 8 or something.
Mommy on mute.
Thank you. Okay. Okay, so that's that. And then this is C. Joining B here, that's supposed to be a straight line. And then this is joining here. That's a D. This is F. 1, 2, 3. A, B, C, 1 and 2. 15 degrees. And then this is parallel to this one. Then we've got D, 1 and 2. And 2 is 50 degrees. Okay. Right. So you are given this, and they're telling you that CE is parallel to AB. Okay. I've shown that on that, and you're given that D2, angle D2 is 50 degrees. Also C1 is 15 degrees. Okay. Then they're asking you to determine the values of angle A, angle C2. And okay, so the first one they want 8.1.1, they want you to get the value of angle A. And then 8.1.2, they want you to get the value of C2. Let's see. Okay. We said if we have parallel lines, can you see? This is parallel to this, right? Let's see the shape. Can you see the shape? So if the line AB is parallel to CE, okay, then alternate angle B is gonna be alternate angle C1 plus C2, okay? And C1, they gave us is 15 degrees. Okay, so that's that. Then again, if the lines are parallel, this will be equal to that. Angle A will be equal to angle E, right? What else? Remember all the other theorems we did. Remember the theorem where angles subtended by the same chord on the same side of the, can you see that? Angle B is equal to angle D2. And D2 is 50 degrees. Okay. So if B is 50 degrees, then the other one, can you also see that angle A is C. Remember to give reasons, ne? This is angles in the same side, angles on the same segment. Okay, this is the same reason. So A is equals to C, C1 plus C2 actually. But we know that C1 is 15 plus C2. Okay, and what are we looking for? We're looking for A and we're looking for C, C2, because we have C1, looking for C2. Okay, so what can we get? Yes?
Ma'am, isn't C2 equals to 50 degrees?
C2.
Isn't C2 equals to 50 degrees, and that the reason is opposite?
Opposite?
And
Yes, you say what's the reason you're saying C2 is 50?
opposite sides have equal angles.
Opposite sides equal angle, or which opposite sides are equal? It's FC equals to FD.
CDF.
CDF. H. But we don't know if this is equal to that. We don't know if this and this are equal.
Yes, sir. Because, okay, yes, sir.
Yeah, unless if they told us F is the center. Let me go back to the question page. No, they didn't tell us that F is the center. They said in the diagram, point A, B, C, A, B, D, and C.
F not the center.
No, They didn't, yeah. They didn't tell us that it's the center, so it's not the center. So they said to us, in the diagram, points A, B, D, and C lie on the circle. CE is perpendicular, CE is parallel to AB, with E on AD produced. Chord CD and AD bisects at F. And then D2 is 50, C1 is 15. They didn't tell us that that is the center. Okay, so we can use F. We can say those are radiuses. Okay. All right, so let's see. What else can we get from here? Okay. C1 and E. Okay. Can you see that D2 is D2, right? Is equals to this plus that. D2 is C1 plus E. The reason being exterior angles of a triangle. Okay. And we know that D2 is 50, C1 is 15 plus E. Therefore, E is going to be equals to 35 degrees. Okay? Happy with that one. So if E is 35, can you see that we can find A? We said A is E. We said angle A is E. Why did we say A is E? Or alternate angles? Okay? Therefore, A is 35 degrees. Okay. What else? We need C2. Let's see how we're going to find C2. C2, where's C2? C2 is here. So A we know is 35. We have 15 here. And we've got C2. Therefore, C2 is 35 minus 15, which is 20. Is it 20? No. B is, wait, where is the other one? Okay, let's look here what's happening here. We said A is C1 plus C2 because, why is that? No, why did we say A is C1 plus C2? This one is wrong. It's not angle on the same segment because look at, you see this, they're suspended by this, and this is not a chord. Yeah, they're not, these ones are not subtended by a chord because this is outside the circle, okay? So this statement was wrong.
Unmute.
Unmute. Okay. Today is just not my day. This electricity, there's no sign of it coming back. Okay, now I'm starting from scratch. Jesus Christ. This is the hardest. Okay, so this was parallel to that. This was E. This was E and B. 1 and 2. This was 50 degrees. This was C. 1 and 2. This is 15 degrees. This is A. B. F. 1, 2, 3. Okay, so we found E was 35, A to be 35 degrees. Okay, now we were correcting the angle subtended by a thingy. So the only angles that are subtended, they must be subtended by a chord. You see, DB, BD is a chord which subtend this angle, and also it subtend this one. So only A is equals to C2. Okay, yeah, so that's that. Therefore, C2 will be 35 degrees because A is 35. Okay, so that's that. So we've got A and C2. The next question, they wanted you to prove that CF where's the question? Prove that CF is a tangent. So 8.2, they were saying prove that CF is a tangent. Okay, let's look where's CF. CF. Oh, CF is here. Okay, they want us to prove that CF is a tangent around which circle? Around circle. Let me go back to the question paper and see. Proof with a reason that CF is a tangent to a circle passing through points C, D, and E. Okay, so through C, D, and E. Okay, so we are proving that this is a tangent of the circle that is through C, D, and E. Some funny circle that we don't know about, but that's what we are trying to prove. Okay, so let's see how we're gonna do that. Remember, with the tangent, there are a couple of theorems. A tangent always perpendicular to the radius, so we don't have a radius, that won't help us. The other one, an angle subtended by a tangent and a chord is equal to the angle in the same segment or the other segment. We have that here. And then the other one is, did someone say something? The other one was, what is the other one? Okay, so there are a couple of those. So now let's see what we can get out of here to see that this is indeed a tangent. Okay, so we know E is 35, A is 35, C2 is 35. Okay, so we know those by now. Now let's find the other things. So tangent CF, which has angle C2, and let's see, what can C2 be equals to? We already know C2 is E. Why C2 is E? Because they are both 35 degrees. Can you see that? And can you see that if I were to draw a nice circle with CD here, this is E, this is D. Okay, and that tangent CF. Can you see that this is C2, this is E? Okay, maybe I didn't draw it properly. It's supposed to be, wow. But can you see the theorem where it was saying an angle between a tangent and a chord? This is the converse of Tangle Theorem. So if you look at the tangent and a chord theorem, this angle, if it's equals to that, therefore, this line will be a tangent, okay? Because there's a tangent, this is a tangent, this is a chord. This angle between a tangent and a chord is equal to the angle on the other segment, okay? So therefore, because of this, we can say that CF is a tangent. This is the converse of Tangle Theorem. Okay, so that is that. Was that all from question 2? Yeah, that's all from question 2 of that exam paper. Okay, it's 8 o'clock, guys. I'm struggling. I can't go any further because I can't see, I can't do much here. So that's about it. All right, any questions, guys?
No, ma'am.
All right, okay. So the other new guys, you guys have any questions? Ruth, Are you fine?
Yes.
Ruth? Okay. All right, guys. I shall see you guys next time. Do you guys want the video of this? It's just a chaos. I don't think I'll send it. It's too many videos because it keeps on cutting and restarting again. Do you guys need it? I don't think so. Do you guys need it?
Yes, ma'am.
Okay, all right.
Yes.
Okay, then I'll say, yeah, I will send it. Who's the other Sigelela Wena at? Is that your sister?
Yes, ma'am.
Okay. Ruth and Sigelela, you guys can send me your email addresses. Then I will share the.
Okay.
Sorry?
We'll send the email address. Thank you.
All right. So you have my WhatsApp number, Ngep? Please.
Yes.
Yeah, all right. So just send your email address. It must be a Gmail because it's gonna be from a G drive. So send me your Gmail address, then I'll share the videos. All right. Okay. Sorry about the chaos because the lesson didn't go as planned, guys. But hopefully it was beneficial. See you guys next time.
Thank you, ma'am.
Okay.
Goodbye.
Thank you.
All right, bye.